Hi, everyone, and welcome to our next installment of Inside the Lab, where you get a chance to interact with some of my favorite people at Phenomenex, gurus of different areas, techniques, and different departments at our company. We like to mix it up so that you have a chance to ask questions on a relating topic to all kinds of people from across our company. So in the past, we highlighted HPLC basics, GC basics, and highlighting, applications around cannabis. Today, we're going to cover mainly sample preparation in relation to biological matrices. How to kind of escape dealing with some of the known compounds and other things that interrupt our analysis, prior to kind of extraction. So I'm going to introduce some of the gurus we have on the line today. Thank you three for joining us. And after I introduce them, they're going to introduce themselves and give you a little bit more information about their background, and then I'll kind of tell everybody how the logistics are going to work for today, and then we'll jump into the questions. So with us, we have Chen from our applications lab. We have Danny Buchan from our account management team, and Matt Brusius from our product management team. So Dawn, if you want to jump in, give us a little bit more information about your background.
Okay, yeah, I'm Dawn Chen. I am an application scientist in Phenomenex, and I have been working on the clinical field for like more than 10 years. And also before that, I have worked on the proteomics on this field. So you're welcome to ask me questions. Thanks.
Perfect. Thanks, Dawn. Danny, you want to jump in?
Yeah, my name's Danny Buchan. I am an account manager. I've been in the forensics team initially for a couple years, so I had a lot of experience helping customers work with blood, post-mortem, pre-mortem, urine, and all various types of nasty samples. Now I focus on the clinical realm and toxicology, so that's sort of my background on it.
Perfect. And Matt?
Hi, my name is Matt Brusius. I am the product manager for sample prep at Phenomenex. I have been with the company for just over 10 years, and I started off in sales, supporting a lot of the same industries that Danny mentioned before he jumped into it. So forensics, clinical application type of work. So yeah, I've been the product manager of Phenomenex for like 6 years now for sample prep. So been real into things like SPE since like 2010. So yeah, it's pretty awesome. But thanks, Simon.
No worries. Thanks, Matt. And my name's Simon. I'm the manager of our global product marketing team. So I'm really lucky in the fact that I get to interconnect and work with all three of the panelists we have today, as well as the departments they're typically in. So it's a fun job that I get to have in terms of interconnecting across all of our product lines and all the people at our company. So logistically, it's going to be easy. If you have questions, relating to this particular subject, or if other things come to mind, throw them into the chat box, and we'll jump through them. We had a couple of questions already come in prior to starting the webinar, so we kind of categorized them, and maybe this is a good way of flowing through today. So we'll kind of start with kind of general overview questions on the topic, and then jump into like specific biological matrices and some of the obstacles, hurdles, or tips that we have. So we'll start with like urine, saliva, plasma, blood, and otherwise. So I think we'll jump right into the general. So again, if you have your questions, throw them in, but we'll start with the questions that we have right now. So the first one came in, and actually this is like a kind of a general one. So maybe I'll throw it to Matt to start, and then Dawn and Danny, if you want to chime in afterwards too. In what ways do you think working with biological matrices is evolving or or has evolved, and then like what specific products or technologies, you know, do you see kind of adapting also with those changes?
Well, I think that, you know, it seems like I guess like slowly evolving, but like the breadth of sample matrices seems to like always be expanding. And so, you know, we getting typically, I think about, or at least initially back like 10 years ago, I think it was, you know, very like urine and whole blood centric. And then, you know, people started talking about, you know, like oral fluid and, you know, and then all of a sudden, I think we start focusing more so on hair types of applications. Sorry, those are my children. So anyways, hold on.
We like to mix it up on the inside of the lab, so you know this is, you know, raw, right? This is not staged. We have dogs, kids, cats, everything's gonna be flying through. Sorry, Matt, keep going.
I just have one dog that likes to bully the other dog, and he's just trying to sleep on the bed and mind his own business, and she just comes in and just I always have to tell her like, leave him alone, right? Like, just such a good boy. So, but anyways, back to your question. I mean, it just seems like it's expanding, right? I think that, you know, as we start expanding the different types of sample matrices, we start, you know, changing around limits of detection, what's clinically significant in terms of the cutoffs. And so I think as the sample matrices evolve, I think that, you know, sample prep becomes, you know, increasingly more important for a variety of different reasons, whether or not it's, you know, trying to remove non-ionic surfactants from oral fluid collection devices, or, you know, even dealing with protein filaments that are just hair specifically. So, yeah, I think that, you know, as the technology increases in terms of, you know, mass spec capabilities, you know, going through, you know, like kind of on-demand testing as like, you know, sort of oral fluid provides the luxury of, it kind of changes the analysis in general. So I think it's the sample prep specifically. So that's kind of how I see it like evolving. I don't really know like, you know, necessarily like what's next, but, you know, a push towards more specific and selective methodology seems like it's kind of in the cards as the sample matrix kind of evolves.
Yeah, and going off what Matt said about sensitivity, like I've definitely seen a trend towards lower and lower limits of detection. You know, back when just the nanogram level was where we were trying to get down to. Now it's increasingly picogram or femtogram. So as the mass specs become a lot more sensitive, we're also seeing a lot more analytes and compounds needed to be detected at a lot lower levels. And so then we find we have to go back and refine our techniques for solid phase extraction, because that becomes ever more important to ensure that we're lowering our baseline so that we can get those the signal to noise ratio as optimum as possible.
Yeah, echoes Dan and Matt's point of view. That's true. Like especially in clinical field, the assays need to be more better. Like for example, in terms of sensitivity, for example, like estrogen is used to measure for the woman like between age of like 20, maybe 20 to like 45, but now this assay pushed to the lower limit. Like for example, we need to measure the like aged woman and even man, or like infant or like children for their estrogen level. That requires assay to be more accurate in the lower concentration level. And also for this like industrial, clinical industrial, like we always want to have like high throughput, like faster automation. That also requires sample preparation, more like automatable and easy to handle and more robust. So that involves the refine of our sample preparation, and of course with the high-end or better instrument as well.
Gotcha. Okay, cool. Thank you all. It's like Don, maybe I'll throw this one your way. What's your process in selection of a surrogate matrix for an endogenous analyte?
Wow, that's really a good question. And actually, there's no like a specific answer for that. So like for us, like for the clinicals, we always want mimic the exactly same matrix as the sample. Like for example, like a plasma or like whole blood. We want our assay repeat what the real life is. But the question is, with the variable of the patient, there's so many like factors. So the surrogate is hard to define. Like I believe for each assay and for different analyte, the answer will be different. Like generally speaking, if we want to use like let's say like a poor sample, poor like a plasma or poor like a whole blood, and sometimes those kind of matrix just cannot work. So we have to use like a surrogate, like even sometimes use like albumin to prepare the samples. Of course, like if we can use the like if we can use the poor like poor samples in the beginning, that would be the best scenario. Hope that answered the question.
I think so. Here's
I
we got
think
another one. Oh, go for it, Matt.
I was gonna say, in some of my experience working with, like, if you have endogenous compounds, really like the only approach that I've ever used is just diluting, right? So like, if you know your endogenous compounds are present at a certain concentration, if you end up, and effectively you're getting further and further like removed from what makes it representative as the sample matrix, but just diluting it out as much as you can to like dilute out the endogenous interferences such that you can spike in like a concentration that's enough so that you can see it. That's kind of like, I don't know, at least in talking to some folks, that seems like one way that they can kind of overcome, trying to get down to, or, just adjusting your calibration curve, right? It's kind of really all you can do, and say like, I'm trying to get down to 5 picograms, but, endogenous level is 300 or something, right? So, I think diluting out was just the only thing I wanted to sort of add. That wasn't clear. So.
That's a great point, Matt. Absolutely. Looks like we got another general question. So for large panel drug screens, that includes kind of both basic and acidic drugs. Or I guess anyone on the panel, is it the recommendation SPE or SLE, and then why? Maybe Danny, I'll throw this your way to start.
For a large like toxicology panel, like yeah, we see a lot of those, and I think it really depends on the lab itself and the workflow that they have. Like I know a lot of customers, if you have a 3200, you might still need that additional sensitivity to where you have to use like a strong cation exchanger like Strata XC, something like that, if you have a significant amount of basic compounds as well as neutrals and acids that can be retained onto the hydrophobic component of the Strata XC media, for example. So that may be of necessity because the SPE is going to give you the cleanest possible sample. And SLE could be a good option, but one thing to keep in mind with SLE, even though it does work extremely well with a wide variety of analytes, basics, acidics, and neutrals, one thing that you do have to tune with the SLE is the pH that you're loading your sample. So even if you have a mixture of analytes and you have a lot of bases, then you want to load the SLE plate at a basic pH to make sure that they're neutralized as much as possible, because if your analytes are still charged, they won't partition as well into the organic eluent. So that's a really important thing to consider. So something that I would jump to actually, instead of just looking at SPE versus SLE, would be a specific urine enzyme removal plate. One example like that is Betagon. It's a beta glucuronidase removal plate that specifically targets and removes the enzyme, which in a lot of these urine panels is the largest contributing factor to to killing columns and causing problems with the analysis. So we want to remove that enzyme. So what that does as a negative process, it's removing the contaminants in a very non-selective manner, allowing all the analytes, whether basic, acidic, neutral, to pass through undisturbed. So that would be a situation to where if you had a more sensitive instrument like a SciX 4500 or 5000, 6500, and you don't need the cleanliness that you will get from an SPE plate, you can use the Betagon enzyme removal plate for a quicker extraction, and it only takes a minute because you're just passing it through like a chemical filter. So hopefully that helps.
Yeah, I think for me with like I think you definitely hit on it, Danny, that with SPE, if it's a super large panel of compounds you're looking at, it's gonna be really hard to tune and optimize for each one of the analytes that you're looking for, right? And then SLE has its limitations in that there's only one pH that you can adjust your sample to, and you're kind of hoping to get everything. And then the benefit of doing something like just sort of chemical filter Betagon is that you're more so, by using a less selective method, you kind of ensure that you're removing the crap that you don't want, right? And then, but also not losing anything that you do want to analyze. So, sorry, I said, I'll do better with my language, Simon. I apologize. I almost made it worse actually with what I almost said following up, but then here we are. So, but yeah, no, I think at first when Danny started talking about the different, it definitely really depends. And I was going to give him a hard time and be like, pick a technique, just pick one. They asked you a question, right? But he's totally right. It just definitely depends on what's important, what the panel is. And I personally, I love SLE, and I will try to use that at every stage possible, but it totally doesn't make sense sometimes. So, but yeah, for sure. Just kind of elaborating on what you said, Danny. So I agree.
Thanks, Matt.
Sure.
I think you guys kind of hit this. This kind of connects to the next question that came through, and they're asking about, for dilute and shoot urine drug screening method, how to extend the column life. And so, you guys kind of touched upon the simplest way, right? So using Betagon to actually remove an enzyme. I know from my perspective, right, from an LC perspective, adding guard columns, and ensuring that you're checking the cartridges in those guard columns and having a method, and a process to continually remove those, or adding specific column flushing would be good. But if you guys have other additional techniques or tips.
Well, I think with the beta glucuronidase removal part, maybe one thing that wasn't super apparent is what relative to something like dilute and shoot, so you're picking a chemistry that cleans up the sample, but the benefit there over something like dilute and shoot is that you're not diluting your sample 10x specifically. So by using one of these chemical filters, you're able to clean your sample up. You're not doing full-blown SPE, and you're maintaining sensitivity specifically. So I think that's an important part of the chemical filter approach. So you're kind of operating within the same time frame that it would take you to do a 10x dilution and inject, especially if you're spinning down, for example. But I think that again, the idea of maintaining sensitivity is really important, kind of tying it back to what Don was talking about in the beginning, and how we're, Don and Danny were talking about, getting these more and more sensitive assays that are coming up, and, especially even in the designer drug space, you start talking about buprenorphine and fentanyl and that kind of stuff, and sensitivity becomes very important, and, a way to maintain it without, again, doing full-blown SPE in some cases is sort of how I see it fitting in. But
and it also depends on how much you're diluting too, because I mean, there's a big difference between doing a 5x and a 10x solution, and cleaner that actually is than undiluted urine, versus if you're going to be diluting 40 or 50 times. So obviously the more that you're diluting, the cleaner your sample is that you're shooting on, but you're also going to have more issues with achieving the sensitivity that you need when you're diluting that much. So it's sometimes you're between a rock and a hard place. You can, not dilute as much, but then you're going to have a much dirtier sample, or dilute the amount that you need to in order to protect your column and your instrument. But at that point, it's going to be a lot more difficult to achieve the sensitivity.
Don, from your experience, are there tips that you have for extending column life when really there's either the minimal amount of sample extraction done or just straight dilute and shoot?
Dilute and shoot is a good way to do, especially for a relative higher concentration. But sometimes you do need like other sample prep method, like for example, the one Matt or Dan mentioned, and also sometimes for the sample like a phospholipid. Like like for example, like our company has like a free plate, can get rid of phospholipid, and that in that way it will like greatly clean up the samples. And it's a simple, easy way to do the experiment and not very expensive. So that's another alternative way to do it.
Yeah, that's a really good point. And phospholipids really aren't something that's thought of, especially with, it's not as much of an issue with urine, but especially when you move to serum and plasma, those have a heavy phospholipid content. And so someone might just be doing diluting or doing like a light protein precipitation, and they think, okay, well, I've gotten rid of my proteins, but you still have these phospholipids that are going to aggregate on your column and contribute to shorter column lifetime. So it's another important thing to consider.
So speaking of simplistic ways of, or more simplistic techniques for sample preparation, question came about around, can we use catchers, right, or dispersive SBE to clean up urine? Maybe Matt, I'll throw this your way.
I mean, you could, I guess. I don't know like why you would want to do that. Sorry, I don't know like the other aspects of like other method requirements, but I'm having like, I mean, you totally could. It seems like it would be a pretty labor intensive process. But like, I mean, there would be no reason why you couldn't. I think it depends on what, making sure that you pick the right SPE kit or catcher's kit. And what would you choose for that? I mean, I guess it sort of depends. I mean, I've never seen like, because everything for catchers is so based around, you choose the catcher's kit based on the sample matrix that you're working with, and like, you're looking for your like fruits and vegetables, and like I don't really see urine on there. It's like one of those things, but I mean, again, the principles are fine. I would think about using like a dispersive, SPE cleanup more so for like a tissue or like filtered homogeneous sample, as opposed to like a urine-based sample. Right, there's a benefit of doing dispersive SPE for solid samples, because the solid samples you're worried about clogging and those types of issues, whereas with urine, you don't really have the same sort of issue. So I don't necessarily know that it would be like my first choice about like how to go about it, but I would think about it for like, dispersive cleanup is more of a solid tissue type of application. And then in that case, I don't necessarily know that I would like call it catchers specifically. I would maybe like homogenize my tissue sample and then subject it to some type of like liquid extraction, and then actually do the dispersive SPE like in a falcon tube with just P18E media or something, for example. But so yeah, so I mean, you could, I mean, I would choose SLE, right? That's what I would do, but that's my opinion. So
yeah, it really doesn't make as much sense, because the DSPE is required because you can't pull a lot of ground up plant tissue through a tube very easily, or a plate, right? So in order to, you really have to remove those contaminants and spin them down using the loose media in DSPE. So with urine, you're not concerned about that because it's going to flow through really easy. So it's a much simpler process to simply grab onto your analytes and wash everything else through. To use DSPE wouldn't be as helpful. And I think I have seen it used in postmortem blood, where you do have a lot of decomposition and problems like that. And I've seen it with, you know, like Matt was mentioning with liver tissue. I believe, you know, if anyone's interested, we do have a catcher's method on hamburger meat, possibly. And I think we've converted that for like a liver tissue analysis. So, you know, if that's something that someone's interested in, you could check that out. But yeah, I would avoid it for urine if possible.
Good call. Don, I'm going to throw this one your way. Can SLE, you know, in general, remove some of the buildup of salts and, you know, that are typically found in urine so that samples can be run on LCMS?
Mm-hmm. So is that the question? So Hope use SLE to get rid of the salts and for the mass spec. So in order to get rid of salts, like SLE is one of the way to do it. And yeah, of course, there's other way, like for example, like SPE or other like catchers can also do the like a similar thing. So it's really like, in my opinion, so like yeah, like there are other way to do it as well.
Cool. And then I think this one kind of leads to that question. I'll throw that to either Matt or Danny, whichever one he wants to answer. Is in the case of using SLE for your key sample prep extraction technique with urine, is there advantages, disadvantages between generic diatomaceous and the synthetic options that are out there?
So I think that the biggest benefit of SLE in general is speed of method development time. I think that, you know, you can really sit down, take an SLE plate, run 3 pHs, 4 solvents, and then at the end of it, you kind of know what you're doing. Realistically, you can usually jump right into your biological matrix. Whereas with like SPE, for example, you're always like, there's this weird in-between phase where you start off in standards and then you transition to biological matrix, and then you're trying to troubleshoot where you're losing your analytes of interest and optimizing wash steps or collecting fractions and changing elution solvents. And like, I'm already getting tired of talking about it, right? So, and you know, actually doing it in the lab is brutal. And so, but your question, I got excited when you said SLE and I raised my hand, and then you were asking me about synthetic versus non-synthetic. And so, yeah, I mean, realistically, SLE is, it's supposed to just be an inert scaffolding that allows you to perform liquid-liquid extraction. And historically, classically, this has been done with a diatomaceous earth, which is a naturally occurring resource. It's a naturally mined out of the ground and the earth or the ocean in some cases. And so there are inherent problems with using a natural resource within the lab. So if you can imagine, the synthetic alternative would provide benefits over a natural resource, in that it's lab manufactured, better batch-to-batch reproducibility, those kinds of things. The caveat to all of that is that it does have a little bit of a selectivity to it that the diatomaceous earth does not have. So, like, the diatomaceous earth-based phases are really good for transitioning like a liquid-liquid extraction over to an SLE plate, right? You can take your same exact liquid-liquid method and put it into an SLE plate, and then you know that you're good to go. The same can't really be said about the synthetic material. It has a little bit of like a charge to it specifically, and so there's certain solvent combinations that won't necessarily like transition over into like the synthetic phase right away. So as the product manager for SLE and other sample prep items, I would try to make the case that you have a place in the ecosystem for both of them specifically. But again, I think that I think and I said this before, and I'm going to say it now that we're being recorded, but in the past, I may or may not have been incentivized to develop applications. And so in doing so, like, what was my first choice? How fast can I make applications? I'm going to run SLE methods, right? So I think it just kind of speaks to the point of like just hitting like it depends on what your goals are, right? Like if you have to develop a method run 100 samples and then move on to the next set of samples, or next type of analysis, then like SLE is totally like the right thing to do in terms of like speed. I think we even know that there are customers that we've worked with that have used SLE plates as like even just screening for eventual liquid extraction methods, right? It's all about the speed of method development and the ease of method development specifically. So I don't know if you guys have anything you want to add on top of that, but I love SLE. So
solid, Matt.
I know how to make you smile now in meetings.
Just talk about SLE.
Yeah, I'll just bring it up. Okay, looks like we got a few questions now to switch into another matrix. So we'll jump into plasma. This one comes across, and Don, maybe I'll throw this your way. Which is the most challenging plasma matrix across the species that you've seen for your experience to work with, like rat plasma, human plasma?
Actually, human plasma is more challenging compared to other species. So like for me, the reason is like human beings are so different, and the population are huge compared to other like species. So yeah, so the good thing is also because the source is available. So like right now there are companies, they can kind of prepare the proper matrix for the research or for the like clinical assay development. Like for example, like they have like a certain like a plasma toward for like a alcohol drinker, or toward for like certain disease, like like heart attack. Like actually it's in a very like fine like category. So that's the good thing for like for human plasma, like in terms of the like challenges. Of course, like whole blood is more challenging. So like in the clinical, we always, if we can use serum, it's better than plasma, and it's better than the whole blood. But this really depends on the analyte we're going to measure.
Thanks, Don.
I would say, like in my experience, it's like sorry, Simon. I remember in like talking to customers, like it seems like like depending on like what the clinical state of it is, but I was just gonna say like high lipemic samples typically are pretty problematic, as I think the name sort of implies, just like within the subset of like plasma samples. I know if your sample prep is like not super on point, then like you can really have problems with ion suppression from various clinical disease states. But high lipemic samples is going to be my contribution to that question.
Actually, on the obstacle side, I think this question kind of combines well. They're asking about what are the MRM transitions that we typically look at to monitor phospholipids, ensuring that they're out of the analysis. If you guys don't remember off the top of your head, maybe referencing where we have that listed on the site.
Is it 190 something? I don't know.
184, 184.
184, okay, yeah.
And that's the chunk, that's the fragment group of the head group for phospholipids specifically. So It's like that, the chunk that represents both like lyso and phosphatidylcholine, so like the single and double chains. You're just looking for that like head group specifically. And you can look at I think it's kind of, I don't know, it's like more interesting when we do like phospholipid like removal studies, really dialing in the difference between like lyso and PC, and like seeing like when it like you'll see the single chain come off of your C18 column sometimes like an injection or two before you see the double chain come off. And so sometimes there's a benefit of like looking for both and trying to understand like more than just like general reading, which is like the 184 fragment. So there can be, kind of benefits of doing a little bit more specific look at the actual phospholipids.
And Matt's also done some post-column infusion studies. I don't know if you, I remember for the SLE plate, looking at regions of ion suppression, and by monitoring the phospholipid and those transitions, you can see and overlaying them on each other, you can see exactly where there's a spike and where we're seeing a lot of phospholipids, and then you see a huge dip in ion suppression for the analytes. So that's something that's also really useful to look at if you have concerns about matrix effects.
That gives you really solid root cause, right? And you know, you see the two things overlap, and when you normalize it, it makes sense. And I mean, I won't talk about SLE anymore, but thinking the thing that Danny was talking about was we were looking at different. So I am going to talk about SLE a little more, but just the type of cleanliness you get depends on the solvent you're choosing, right? And so we were screening different solvents to see which ones got rid of the phospholipids better than others, and just remembering that hexane was a good one for the cleanliness aspect of it. But yeah.
Right, yeah. And as far as finding it on our website, I know if you at least Google Phenomenex free phospholipid removal, you can see some of those transitions on those pieces of literature that we have on our website for free, PHREE. It is not free as in F, free.
Those marketing people come up with these names.
Yeah.
Marketing's the worst.
This question actually kind of goes back to Don, what you were mentioning. They wanted to know about the difference, between serum and plasma. Why do you prefer working with serum versus plasma?
Normally, there are more active stuff in the plasma rather than serum. So when we normally, especially for the a spike in samples, when we make the calibration curve, and if we spike in standard, if there's some if there's something in the sample in the matrix, they could interfere with the analyte, for example, degradation, or the analyte could bind for those compounds. So in that way, make the assay a challenge. So that's the reason, compared to the plasma, serum is more it's more stable or less active. That's the main reason.
Perfect. Thanks, Don. It looks like we kind of got a question that combines with plasma and saliva. So would sample prep be similar for plasma and saliva? Yes, I'll throw that to any of you guys.
That question,
I mean,
for Matt. Sorry. Yeah, go ahead, Matt.
Oh, sorry. No, I mean, I think it'd be very, very different. I think that when you start thinking about saliva as a sample matrix, you're kind of at least starting to think about what type of, how are we collecting it is a big difference. Is it in some type of, what kind of collection device are we using? It's not usually just, you won't receive just saliva, just uncut specifically, right? You get it with a bunch of non-ionic surfactants and, stuff, dyes and things like that. So I think that really what's important for qualifying what a saliva matrix is also the collection device that you get it in. And so then, that's just a completely different sample matrix than you would receive, or how you would receive your plasma or serum. So, I think it would be wrong to think that there's maybe there's salts and maybe a little bit, I guess there's a little bit of protein in saliva, right? There's lysozyme in there, which is an innate function of the immune system. But yeah, so I think you treat them very differently, to answer your question. It wasn't directed at me, so sorry, be quiet.
Okay, so it looks like we'll kind of jump in to some other saliva questions then. So maybe Dana, I'll throw this one your way. Would protein precipitation be enough of a sample prep technique for saliva samples, or do you need to go to a more selective technique like solid phase extraction?
It would be nice if protein precipitation was enough, but unfortunately, like Matt just highlighted, there are some proteins in saliva like lysozyme and I think amylase and some other things, but that really isn't the primary component that we're worried about when we're doing saliva analysis. The primary components are going to be those buffer surfactants from the oral fluid collection devices, and those, things like tween and, those other like synthetic surfactants do not precipitate out just with a simple protein crash. And the only way that we have found to really get a clean sample that's going to be good for your instrument and for your columns is by doing solid phase extraction. There really is no good alternative in order to give you as strong of a wash that you need to remove those surfactants. So what we have to do is use ion exchange, because if we just use a standard reverse phase SPE cartridge, all of those surfactants are going to stick to that too. So we use a two-step method we found to be our premier comprehensive solution for oral fluids. And that uses Strata XC, which is a cation exchanger for the bases, Strata XA, which is an anion exchanger for the acids. And by utilizing these two different types of SPE phases, then that allows us to do a very strong wash, strong organic wash that flushes out the surfactants. And that cuts down on the background noise and ion suppression and other issues that those surfactants are causing, in addition to killing the column sooner. So yeah, SPE ion exchange is the way to go for that.
I think even the wash step in that method is like 50% acetone or something. Mm-hmm. So it's not like with a lot of the reverse phase stuff, you're like 30% methanol, 50% methanol, but like, I don't know. It speaks to the like stickiness or the difficulty of removing those. That it seems like it's just like a mixture of surfactants specifically, and may or may not be changing over time and stuff. It's really hard. It's just that whole like collection device is like kind of a sample prep nightmare. So we're not just trying to sell you 2 SPE cartridges because we want to, right? Like I think that it speaks to like how difficult the sample matrix is, and there's kind of like no like really awesome sample prep method, right? It's 2 cartridges, or you're going to start sacrificing cleanliness and system maintenance, all that kind of stuff over time. So there was actually a moratorium on being able to run oral fluids at Phenologics maybe like 5 years ago, because somebody that was doing development with it, they just kept running samples and they ended up having to get the rails scraped. And so there was like a very much like a hesitation to even like pursue these types of applications for a little while on our side, but we figured it out, and just, I don't know, again, just like highlighting the fact that it's just, if you don't do appropriate sample prep, you can, really cause some unwanted downstream issues for you. I know, like, and I guess even if like sample volume's not that bad, but like we've seen, I think me and Danny have seen people that have run like the same SPE protocol or same sample prep protocol they have for their urine with oral fluid, and you just kind of like get like a little bit concerned is all. Yeah. So yeah, it's a monster in and of itself. So
yeah, for the there are many differences between the plasma and the saliva. So one of the issue with the saliva is the concentration. So that's part of the reason we use SPE, because unfortunately, the analyte concentration in saliva, not all of them, but lots of them, concentration are quite low. So that's the reason we want to use SPE to enrich in spite of clean up.
Perfect. Thank you, 3. Kind of a related question, it looks like. So does the recommended method for oral fluid change based on the brand of collection device or the buffer solutions?
No.
I'm gonna go with no. No. Yeah, I mean the note that it's I guess between the two different ones, the Quantisol intercept and oh god, I'm blanking. Danny, help me out. All right, this is my second on-time camera of on-camera variety in the last 2 hours, and then I had to talk to my boss in between, which is just worse, right? Like Simon knows my boss, which is why he's laughing. So
it's not that bad.
Anyways, but no, the SP protocol is the same between the two like most popular devices, Orsher and Quantisol. That's what I was trying to say. There we go. So
cool. Thank you. Okay, I'm going to throw a wrench in this. So we've hit upon we've hit upon urine, plasma, saliva. So we had a question come in that about animal fecal analysis. So I figure I'll throw this into you all. It's just a general question. So they said, have we seen an increase of the researchers, or our customers asking for that type of analysis or extraction methods for that?
Are you saying animal just like non-human or human as part of an animal? I guess
Good
I would
question.
ask that
Maybe both, yeah.
Because I mean,
I think
from
from
my standpoint, I haven't seen like, veterinary animal samples, but at least from my perspective. But, as part of the increase in omics, right, proteomics, metabolomics, now the microbiome is such a huge thing. There's so many companies that are doing at home like gut biome screenings, right? So you take your own sample and mail it in, right, and they'll do testing and tell you, about your gut biome and what that means about your diet or disease states or whatnot. So I think as that becomes a more important and prevalent part of disease research and personal wellness, it's becoming a larger topic that I've seen. So that's human as part of animal, and usually the sample size is pretty small, and you really have to be catching a wide swath of analytes. So it has to be very generic, which I think is one of the difficulties of it. Anytime where you don't have, not just one analyte or 5 analytes, in like these metabolomic type studies, you're looking at 1,000 analytes, and then it becomes a lot more difficult to remove your unwanted contaminants and retain what you need.
Cool. Thanks, Danny.
Yeah. So, do you have anything to say about this, Matt?
Oh, they actually came back and said it was non-human.
Oh, non-human.
Oh,
I got
okay. Yeah. So yeah. Okay. So my answer for this question is, yeah, of course, like in academic, like lots of samples are not human, like non-human, like from rat or from like monkeys or from like even from fish, like yeah. So there are difference between non-human samples and humans. Like for example, like a metabolite pathway will be a little bit different, or the proteomics, the amino acid sequence could be different. So like in my mind, like those kind of difference highlight the uniqueness of your like method development. So those are the key point we have to pin on. So that's one thing we have to consider. And another thing, of course, those kind of difference like promote like better chromatography method and also better like mass spec instrument. So that's another issue. It's like everything has advantages. Like for example, like in terms of like develop like a quantitation method, we can like for example if we want to develop like a if we want to measure humans, we can use like other species, like exactly same, like same compound, same analyte with different sequence or a little bit different structure as the internal standard. That's a very good way to develop method. So it's like, yeah, so it's like, yeah, it's beautiful. There are so many like types of the like similar structure compound there, but we can use it. So yeah, that's my compound. That's my comments.
Perfect. Thanks, Don. Thanks, Danny. Maybe we'll jump in some of the next questions that it look like they relate to one of the toughest matrix that we kind of run into pretty commonly. I think you guys all, and that's blood. So Matt, maybe I'll throw this one yours to start. What's the best way to pre-treat whole blood prior to the cleanup step?
Zinc sulfate hemolysis, protein precipitation, SPE. That's my answer. Final answer. Regis. Sorry. So yeah, that's funny you asked me that, because that was what I just gave my mediocre presentation before this on. Not like the content, just like the. Anyways, it's fine. But yeah, no, I think that you can go about. It's really, you kind of have to treat whole blood. Like, I think the way that I think about it is two different components. So you have the plasma component, and then you have the red blood cell component. So the plasma component you can treat just like we talked about, how you would normally treat plasma, which is protein precipitation. And then the red blood cell component, I think you have to make sure that you get all of the stuff that you're looking for out of the red blood cells. So you have to make sure that you're lysing your cell appropriately. So historically or classically, that's usually done with some type of like osmotic breakdown that you will combine with some type of physical denaturing. So basically just diluting in water and sonicating, or diluting in water and vortexing. I think that has kind of been supplanted as the gold. That's been supplanted as the gold standard by chemical denaturing, chemical hemolysis. So using like a zinc sulfate solution to perform the lysing of the red blood cells. It acts like a chelating agent, and then just physically it forces, chemically opens them, as opposed to creating just like a hypertonic solution that like pops them open specifically. So folks seem to appreciate that a little bit better. And then just I think that it depends on what your secondary cleanup step is specifically, and like what your goal of analysis is. Like if you're doing a whole big panel, or if you're doing a couple, like I think that like the amount of work you have to do up front determines like how wide of a net you're trying to cast specifically. So like if you're trying to do a really large panel and you are only using like a pretty like weekly washing SPE method afterwards, you probably want to do protein precip to reduce the sample complexity, sample matrix complexity before you go to like LCMS. And so that being said, if maybe you have the luxury of like just tuning in on a particular class of compounds, you might be able to forego the protein precip, just like dilute and buffer, and then perform SPE. So if you're, so it sort of depends. But I'm gonna stick with my original answer that zinc sulfate hemolysis, optimizing the particular type of protein precipitating reagent you use. Usually a good mixture is like binary mixture of acetonitrile and methanol are usually really good. Specifically because acetonitrile is really good at precipitating proteins, and then methanol gives you like increased solubility of particular compounds. So kind of using the best of both worlds. A lot of times if you're working with like really hydrophobic analytes, they don't like to dissolve into acetonitrile because of how polar it is. So methanol kind of helps like with the solubility aspect, but then again, using acetonitrile is that like really efficient precipitating reagent. It's kind of like a good way to go about it. But I think that is a much better summary than I gave this morning. That was like my my second chance. So
luckily this is recorded.
So luckily, yeah, that's great. Maybe Jeff can see when I put something bad on him. What's up?
So yeah, everything that Matt said was perfect, because he's the man. And and there's one thing that I have seen with zinc sulfate that it's important to keep in mind, that there is another component of blood that a lot of times is overlooked, and that's the preservative, right? Because you don't just get blood straight, usually EDTA, or sometimes it's like a potassium oxalate, sodium fluoride, like additive that's helping to preserve it and keep it stable. So, and anticoagulating. So it's important to understand like that component of your sample too, because if you are doing a certain pre-treatment, you want to make sure that what you're doing isn't going to be having any adverse reactions to the preservatives. Like for example, I've seen cases where, you know, we were adding zinc sulfate, and then we kept seeing this weird, you know, green precipitant come out, and it turns out that the zinc sulfate was reacting with like the potassium oxalate and sodium fluoride to like have this precipitate come out that was like another dirty part of the sample. So, you know, making sure that you understand what that preservative is can also like help you, you know, in cases where you do have some adverse reaction, which is rare. I've only seen it a couple of times, but it's one thing to where if there's something you're banging your head about and it doesn't make sense, you know, that's another possibility.
Perfect. Okay, looks like this one kind of connects back to oral fluid also. So in what applications can oral fluid replace blood? And then is the accuracy affected?
Oh, this one, the easiest answer is the COVID. You know, like the PCR, like they don't need the quantitation. Like actually quantitation is not the big issue here. They just want to do the identification. And then like so like, and the COVID, like with so much, like, yes, so many people need to be tested, and with the fast, easy way. So like saliva is much better than the blood. So that's the easiest answer. Of course, there's other way.
I think that, I mean, I don't know, it seems to be pretty, like, depending on what the jump is, like, I mean, oral fluid is effectively a filtrate of your blood system, right? So I think it definitely depends on like what you're looking for, and, you know, if it's in a reasonable enough concentration that you can actually detect in your saliva, and then, you know, whether or not that makes sense for, you know, what it is that you're trying to do. So just kind of like more questions for the question about, you know, exactly what it is, and see where I would go with that. But
yeah, I think the context is like, where are you taking it to? Because most of the cases where we see oral fluid is for drug analysis, in which case it's being done in lieu of a urine collection, because there's a lot of pitfalls, you know, because you have to watch them, or like, you know, making sure there's no replacements or additives that have been added to urine, right? So you can watch someone directly take an oral fluid sample. It's not as hard to fake. It's not as easy to fake. And you can do it off the side of the road if a cop pulls somebody over. But those are situations where you'd be replacing urine as opposed to blood, which would be more likely to be taken in like a hospital or like a morgue setting, usually.
Yeah, another consideration is the timing. So like, for example, like saliva, like if people just admit, so they can find some trace in the saliva, and later on maybe a few hours in the urine. But like normally in the blood, it will last days. So like, yeah, so that's like I echo with them, like Dan and Matt. So it's really depend on what you are looking for.
Perfect. And on that segue, I'll kind of close this up. I think we're all looking for interesting knowledge and tips and tricks and the techniques and the analysis that, you know, we're involved with on a day-to-day, and our customers are obviously looking for the same thing. So just want to take a quick second. Thank you three for taking time out of your day, you know, and adding a little bit of levity within this webinar that now will live in infamy. for forever. But also wanted to, shoot obviously a quick thanks to all our customers on the line, and all that may be watching this, on demand in the future. We appreciate all the work that you do, all the incredible science that you do on a daily basis, and the way that you share that with us. And we love to hear about your successes across the board and how you're pushing the boundaries of science. So plainly put, I wish you all, that you're staying safe, you're staying sane, and most of all, stay curious about chromatography, because we love that too, and we love hearing back from you too. So thank you all for attending, and in the future, we'll have other topics coming through for this type of webinar interaction. I believe the next one up is going to focus on characterization and extraction of oligonucleotides, more specifically synthetic oligonucleotide therapeutics. So it could be in relation to bioanalytical or even scaling up in terms of the production of these types of therapeutics. So look on the horizon for that. And likewise, we'll have others coming through. If your questions, didn't get answered, if you have other ones, just head on over to our website and go to the chat now link, and you'll be able to talk with one of our technical consultants right away. But thank you all again, and hope you have a lovely rest of the day.
Bye. Thank you.
Bye.
Bye, guys.